Okay, so today we're talking about the multiplication principle and counting principle and permutations. Okay, so let's start with the easier stuff, counting principle. So if the question is about, how many ways can you do this? How many different pizzas could you make with these toppings? Or how many different ice creams could you have with these flavors? How many different license plates could you have? Those are classic kind of questions. So let's learn a couple of techniques. So this restaurant offers a three-course dinner menu. Customers who order this menu must choose one appetizer, one main dish, and one dessert. Here are the options for each course. Okay, so you've got a bunch of options there, but you're going to get one of each, right? So you got first you've got three appetizers to choose from, then four main dishes, then two desserts. So what do I do with those three numbers? That's really the gist of this. The counting principle is almost intuitive. How many different meals can be ordered from this menu? That's the classic question, right? You could try all possible order. So maybe you go butternut, then pork chop, then chocolate cake, right? Then you try butternut, then pork chop, then apple, right? So you go through every possibility. You start listing them out. Can you imagine doing this for everything? Well, it's like we're listing them. Might be easier to display them as a diagram. So actually a tree diagram makes sense. If you're a visual person, this will actually make more sense in your brain. You have three choices to start with. Then once you make one of those choices, you have four choices that sprout out or branch out from those three choices. So right away, just with those two things, you have 12 options, right? 3 times 4. You get the hang of how we get 12 there. And then we add two more for each. So you go 3 times 4 times 2 will be 24. Four choices, so you literally just multiply the numbers. It's called the counting principle. Okay. That's the formula for it if you want to write it down, but basically like how many different ways you're going to multiply the options. Okay, so this is a pretty good example of the license plate, pretty classic. Passengers have one digit followed by three letters and then three more digits. The first digit cannot be a 0. The first and third letters cannot be I, O, or Q. Interesting. How many possible license plates are there? So let's just kind of go through this. Let's pretend we are going to solve this. Okay, so I would write out the blanks there because we're going to multiply here. So let's see, we've got 7 characters. Oops. One, two, three, 4, 5, 6, 7. So the first one is a digit, but it cannot, so no 0 here, no 0 for this one. So normally there would be 10 digits, 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 counts as a digit, but because we can't count 0, it's just 1 through 9, which is actually only 9 choices, times the first and third letter. So this letter has a cannot be an I, O, or Q. So it could be any of the other 26 letters. So there's 23 options for you. Middle letter evidently can be all 26, but the third one also has that same restriction. There can only be 23 options. The last digits don't seem to have any qualifications to them, so it'd just be 10 times 10 times 10. And then you get your calculator out and you get the answer. You just multiply those out. And I think that's what we got. 123 million possibilities. So you can keep their license plate like that for a long time and they don't have to expand it at all because they have a lot of options there. So you have 5 framed photographs of different family members and you want to arrange them in a line on the top of your dresser. How many ways can you do this? So the thing I used to say in algebra 2 is order is important here. So the order of this is all about order. You're ranking, or you're kind of putting these in order. So order is important. So this is a permutation. But you could do the slot. I call this the slot method. You write out the 5 slots. You go, how many options are there for the first number? 5. And then 4. Once you've chosen the first one, there's only 4 left for which ones you could put next. Then 3, then 2, then 1. You multiply those out. You get 120 different photo options. We call those permutations because order was important. Okay. We think we're cool and we write 5 factorial. So 5 factorial means there's 5 times 4 times 3 times 2 times 1. You don't have to memorize that formula. Usually we're going to get our calculator to do most of that stuff. So, manager of a youth baseball team has picked 9 players to start an upcoming playoff game. How many different ways are there for the manager to arrange these 9 players to make up the team's batting order? By the multiplication counting principle, there are 9 options, right? So there's 9 different people we could put in the first batting order, like to bat first. Once you've chosen that person, he's not eligible for the other options, so there's only 8, and so forth. Multiply that out, or just type 9 factorial. So to do that, let's see if we can do that. So if you go to like a scratch pad or something, if you type in 9 factorial, I think is down here, the question mark, and then you choose the second option, and you could type it like that if you're cool. So. Order matters for permutations. That's true. Rook likes to get students in the stats class involved in the action, but he doesn't want to play favorites. Okay. So he puts the name of all 28 students of his hat, mixes them up, he draws out three names one at a time. 3 students are given a job. Student 1 operates and displays the calculator. Student 2 reads the homework answers, and 3 writes the notes on interactive whiteboard. In how many ways can he fill these 3 jobs? So you can't have, once you've chosen one person, right, there's no option for them to do the other job, right? So each one, there's 28 students in the class, right? So you do 28 times 27 times 26. You're choosing 3 things. There's 3 events that are happening there. And you're just going to multiply counting principle again. So that's not the full, that's not 28 factorial. That'd be a really big number, right? So you're limiting it to just the first 3 have jobs. Not everybody has a job. So the other way of doing this is to use this notation 28P3, which means it's similar to saying NPR in your calculator. That's how it notes it. It's called a permutation. N is like the total kind of you're taking. R is how many you're taking at a time. It is a calculator command. So if you type in, so let's get there. So if you go to menu, algebra, maybe number, let's see, number tools. Wait, what am I trying to do? Sorry. Probability, that's where it's at. It is a permutation. There it is. So menu 5.2. Sorry, it took me a while. Menu 5.2 is permutations. And so if I typed in 28, 3 there, it should give me that answer, 19,656. Let's see what the answer was. Yeah, that's it. So you can notate it NPR. It's not the public radio station. It is, so these are different kinds of permutations. R individuals selected from the entire group of N individuals. So N is the entire group. R is the ones that were selected. Youth baseball team has 15 players. How many different ways for the team's manager to arrange 9 of those players in the team's batting order? So again, you're not arranging all 15 players, so it's not just a straight up factorial. So you're going to have to use NPR. Order is important. Which way you bat first, oh man, makes a big difference in baseball. So it'd be NPR 15, 9. That's all the different batting orders. And that is how you could solve it. You could use the counting principle essentially and just, put out the 9 options there, the 9 different batting orders in 15 times 14. It's not the full factorial, it just goes down to 7. You could also try it in the calculator. So let's get that calculator back out. So if you get NPR, let's copy it, 15, 9. Wow, it's a big number. Let's see if that's the same number. It is 1,816,000,000. Okay. Okay. A little clever math. We can rewrite 15p9 as follows. Oh, that's kind of interesting. This is the derivation of the formula. I don't think you have to write this down. The calculator is going to do NPR for us. I just need to recognize, hey, got an orders important, going to use NPR here. Going to use permutation. I don't think that's that important, but 0 factorial is 1. If we divide by 0 factorial equals 1, the values obtained by the two methods agree. So it's just a different way of showing it. Okay, so let's try this one. Local ice cream shop. It's called 21 Choices because they offer 21 different flavors. Love it. This person likes all but 3 of the flavors. That 21, except for Choices offer bubblegum. Likes all but 3. So he doesn't like bubblegum, butter pecan, or pistachio. Ugh. So 21 Choices are the basic sundae, come in 3 sizes. Small, medium, large, includes 1 flavor of ice cream and 1 of the 12 toppings. Dontrella has enough money for small and medium basic sundae. How many different sundaes could Dontrella order with only the flavors he likes? Wow. The qualifications for that one here. Okay, so let's look at the small first. So he's got to choose comes in 3 sizes. Okay, then 1 flavor of ice cream and 12 toppings. So for the small, it'd be 1 flavor of ice cream, which is 18 options for him, even 1 of 12 toppings, so 18 times 12, whatever that is. And then for the medium, it'd be 18 times 12 again, right? It equals that number. And then you're going to add up those 2 numbers to find out how many different sundaes he could order. Because he can't order the large. I was just double checking the question. I want to make sure that large we don't calculate here. It's kind of sneaky. You had to read that. I think that's right, though. Dontrella could order a cone with 3 scoops of ice cream to have, let me see. I'm not reading the whole question. 3 instead of a sundae. He prefers to have 3 different flavors for a variety, and he considers orders of the flavors is going to be important. And I kind of agree. How many 3-scoop cones with 3 different flavors that Dontrella likes are possible at 21 choices? So because order matters, we can use a permutation. If he hadn't said that thing about the order of the scooping, we could not use permutation. It'd actually be a combination, which we'll probably learn about next chapter, next section. The 3 different flavors, consider order of the flavors that are going to be important. How many scoops from different, so possible 21 choices. Okay, but Dontrell doesn't like 3 flavors, right? So I'm a little confused as to whether or not we include that or not. But I'm going to not include it because he doesn't like it. I don't want to get him pistachio. Make him have to eat that. Okay. So how many 3 different flavors are possible? 21 choices. So, and using NPR. So we've got 18 and he's choosing 3 of them. So 18P3 should be that's all the options he has for the ice cream, right? Which I don't think they're doing toppings. It's just 3 scoops of ice cream, right? So assuming that he doesn't want any of the flavors he doesn't like, which I don't know why he would want those. And then you would type that in your calculator to get the number answer. That's your lesson for today.